ते नंतर edit करतो ना. Hello students, good morning. Today we can solve another one numericals on beam strength. So the question is the following data is given for a pair of spur gear with 20-degree full depth involute teeth. Number of teeth on pinion equal to 24. F teeth of the gear 56. Speed of the pinion is 1200 RPM. Module 3 mm. Service factor is 1.5. Face width equal to 30 mm. Both the gear are made of steel with an ultimate tensile strength of 600 Newton per mm square. Using the velocity factor account for the dynamic load. Calculate first beam strength, second velocity factor, third one rated power that the gear can transmit without bending failure if the factor of safety is 1.5. So look at here. First of all, we can write down the given data. So this is the 20-degree full depth involute teeth. So the number of teeth on pinion, so we call as the ZP equal to 24, and ZG number of teeth on gear is equal to 56. The pinion speed NP, which is given 1200 RPM. Module M is given 3. Service factor CS given 1.5. Face width B is equal to 30 mm. And ultimate tensile strength SUT, which is given 600 Newton per mm square. And next factor of safety will be given 1.5. So look at here, we can solve this numerical. First step, so both the material are same, which is the steel. So now the ultimate tensile strength of both the material is 600 Newton per mm square. First of all, you can write down both the materials are same, so that pinion is weaker than gear. So design for pinion. So first of all, we can write down the formula of beam strength SB equal to MB sigma B into Y. So we know that M already given 3 mm module, face width will given 30 mm, sigma B and Y we can calculate. So we know that from that table number 17.3 for NP, ZP is equal to 24. So therefore, from table number 17.3 for the Bandari book, which is Y equal to 0.337. Okay, so now we can calculate sigma B. So now the sigma B is equal to 1/3 of SUT. So here 600 SUT given divided by 3, which will be the 200 Newton per mm square. So now we are putting all these values. SB 3 into 30 into 200 into 0.337. So which will be 6066 Newton. Okay. So next, once we know that SB is 6066 Newton, so now the P effective, which will be the P effective is, so now SB equal to factor of safety into P effective. Okay, so now we can calculate the P effective. P effective equal to SB divided by factor of safety. So SB is 6066 divided by 1.5. 4044 Newton. So now then P effective equal to CS divided by service factor divided by velocity factor into PT. Okay. So now we can calculate the PT. So once if you calculate the PT, then you can calculate the MT. From that we can calculate the rated power. Before we are going, we are considering for initial stage of design for velocity factor, account for velocity factor. So now we can calculate the CV. So before calculating CV, we know that first upon velocity. On that we can calculate the CV. So velocity we can calculate by the formula which is pi d dash p n p divided by 60 into 10 raised to 3, which will becomes in meter per second. So we know that 3.14 into dp we can calculate the pitch circle diameter of pinion, which is m into zp. 3 into 24, which is 72. Okay, so we are putting 72 here into 1200 divided by 60 into 10 raised to 3. So now velocity will be coming, which is 4.523 meter per second. So which is less than 10 meter per second. So now our CV formula, CV is equal to 3 divided by 3 plus velocity. Okay, so 3 divided by 3 plus 4.523. So now we are calculate the CV 0.398, and next we already know that we can calculate PT. PT is equal to P effective into CV divided by CS. So P effective is 4044. CV already calculate 0.398, which is divided by CS 1.75, 1 point, sorry, which is 1.5. So now the PT, which will coming 1074 Newton. Okay. Once if you know that the PT, so we can calculate the torque MT. MT is equal to PT into D dash P divided by 2. 1074 into 72 divided by 2. MT is equal to 38,636.64 Newton mm. Once you know that, torque MT equal to 38,636.64 Newton mm. So the rated power equal to 2 pi m t 2 pi n m t divided by 60 into 10 raised to 6. It will be directly coming in kilowatt. So 2 as it is, pi 3.14, so that np, which is 1200, and we are calculate mt 38,636.64 Newton mm, which is divided by 60 into 10 raised to 6. So now the rated power is equal to 4.85 kilowatt. So this is our third answer.